Hey guys, this is Adit, and today we are going to solve the some binary tree problems, and that are like okay. I'm going to share my screen. Okay, is it visible? Yeah. Okay, I have some problems. I have to write so for you. Okay. In the previous video, we have done the count total nodes in a complete binary tree. Now in this video, what we will do? First, we will study the requirement needed to construct the binary tree, unique binary tree, and construct a binary tree from pre-order and in-order traversal. Then construction of binary tree from post-order and in-order traversal. Okay. Now serialize and deserialize the binary tree, and after that more is in-order traversal or more is pre-order traversal. Each question will be covered in today's live stream. Okay. I I have to open the PDF. Like I think I have photo. Yeah, I have one photo. Okay, look at this. Can you see that? Okay, I haven't ticked this, but you, I will tick that after some time. Okay. Now in this today video, what we will do? We will first study the construction properties. Construction property of a binary. These are 1, 2, 3, 4, 5, and 6. These 6 will be covered in today's live stream. Okay. Now see, first understand what the now see the requirements needed to construct a binary tree. Okay. Now okay, go to the top. Okay, now first understand the why the which are the requirements that we should know before constructing the binary tree. Okay. Now see if recording several sequences they pre travel sequence if you don't know the binary tree task with to construct a binary tree. Now see what is uniqueness. Unique is important because it specifies there should be a distinct and singular element of a node within a tree. Unique binary means that there is only one possible tree structure that matches the given traversal sequence. Okay. In the word unique, while not specified, there might be multiple tree structures that could correspond to the same set of variables, and making it harder to determine the single valid tree. We will now explore the scenario where the pre-order, post-order, and order tables are given two at a time. Okay, here we have given pre-order and post-order tables. So, as we know that in the pre-order tables, the first value that we write in the table or it write in a array, that is the root, and the same value that will be come in the last of the post-order table. Okay. Now if we see that the array of 1 means pre-order traversal, 1 is in the 0th index, means it is the root. Okay, so 1 is the root, and if I see that 2, 2 is coming after 1, and if you see the 2 where it is coming in a post-order traversal, it is also coming in the 1 index, means the left child of 1 is 2 and the remaining child, and that is 3. That is the left child of the 2. We have 1, 2, and 3. We can also say that 1, 2, and 3. That can be also, but it can be also one binary tree. For example, both of the binary tree have the same pre-order post-order tables. Now, from this pre-order table cell and post-order table, it is not possible to construct a unique binary. We don't know, like, mm, should we go with the first of the binary tree or should we go with the second binary? Because both are different, but both are coming from a two means one pair of pre-order and post-order. So for constructing the unique binary tree, we have some conditions. Now see that if you have pre-order and in-order, okay. Now pre-order traversal, as, as we already learned that the pre-order traversal first node is the root node, means 3 is the root node, okay. Now if I see in order traversal, okay. Now check what is in-order traversal. In-order traversal means first we will go in the left, okay. Then we will traverse the node, then we will go in right, okay. Now, now see, if the root is 3, okay, so search the 3 in the in-order traversal. 3 where after the 9, 3 at the position, okay. Now 3, the total number of element in left side of 3 is 1 and total number of element in right side of 3 is 3. Means 9 will come in the left child of the 3 and 15, 20 and 7 will go in the right sub 3, okay. Now again see for 9 and 20, 15 and 7. If you see, like, 9 is the only child, okay, so no need to go anywhere, okay. So we will return and we go in the right subtree of 3. Here we have 27 and 15. If you see, in pre-order traversal 20, 15, 20, 15 and 70, which number is coming first? Okay, now see, 3, then 9, then 20. It means 20 is coming first. It means after 3, the in a right subtree, the root value will be the 20. Okay. If I scroll down, means, okay. Now see, 20 is the root node. Now see the in-order traversal and find the 20. I have 20 and left. If I go in the left of 20, I found 15, 3 and 9. 9 and 3 are already arranged, but 15 is not. So what we will do, we will add the 15 in the left subtree of 20 and remaining will we go in right subtree of 20. Here we have two values, only 15 and 7. So we will attach the 15 in the left subtree of 20 and the 17 in the right subtree of 20. Okay, we have attached the nodes. Now we have a complete binary tree, means not complete binary tree, and we means according to the situation we make our made our binary tree. Okay, now we have to write the algorithm for this to construct a binary tree from these two in order or pre-order traversal. Now see, if in order traversal the sequence start with the root node and then we explore the left subtree before the right subtree, and knowing the first element and they all are given that I already explained you. Okay. Now construction from pre-order and in order. Here we have pre-order in order. Now see pre-order and post-order. Pre-order and post, what we have to do in a pre-order, in order and post-order. In a pre-order, we are seeing the value from left to right. But if you have given a post-order traversal and in-order traversal, that then will see the value from right to left, and the same process will be applied for the in-order traversal. Means we will check that value, like if I apply that is post order traversal, then we will check from right to left and we find the 7, then we will search the 7 in the in-order traversal and the 7 is found, then the left will be the 9, 3, 15, 20 and right will be the null. Okay, so same for the post order and in-order traversal, just opposite of that. Okay, now case of the full binary. Case of the full binary, in case of the full binary, every node has either 0 or 2 children, means there is no ambiguity regarding the structure. Okay, Due to the absence of the node with the single source of tree, the pre-order post-order traversal provide enough information to immediately reconstruct a full binary tree. It means the fixed structure of a binary tree without nodes having one sub-tree allow for unique construction using the pre-order and post-order traversal. Okay, we have binary tree from pre-order and in-order traversal. Okay, now if you see whether replace the 4 to 5 hot tech roles that are being hired in IT industry, deep in the software development. Okay, I haven't. Hello Deepak, think hey Deepak Chintala, if you read this, what tech roles that are being also for. Okay, now we understand the how to construct a binary from pre-order traversal and post-order traversal. So we will mark the the table requirement needed to construct a binary tree, but we have to find. But if we want to construct a binary tree, then what are the requirements? First is we have to know the pre-order traversal or post-order traversal along with the in-order traversal. If any of two are given, then we can construct the binary tree from scratch. Okay. Now, second one is construction of a binary tree from pre-order in order that we have learned. Okay. Now, construction of a binary tree from post-order that we already explained. I already explained. Now, serialize and deserialize the binary tree. What it means? Serialization and deserialization of binary. Serialize and deserialize of binary. Now understand what it is serialize and deserialize a binary. Now, for given a binary tree, design an algorithm to serialize and deserialize it. There is no restriction on how the serialization and deserialization take place, but it needs to be ensured that serialization binary can be deserialization to the original tree structure. Serialization the process of translating the data structure or the object state into the format that can be stored or transmitted, for example, across a computer network and request later. The opposite operation, that is extracting the data structure from stored information, is deserialized. Okay, if you see that I have binary tree, no, I have tree store. How the tree is stored in an array is how the tree Okay, if you see how tree is stored in array, okay, now here we have the formula. Means if you have n number of childs, means the root node will be stored at the zeroth index. The left child means the left child of the root is stored in 2I plus 1, means 2 into 0 plus 1 means 1th index, and right child will be the second index. It means that if you have array like see this image, okay, if you have left child, right child, right, now if you have 10, then 10 is stored at the 0th index. If you have 9, that is the left child of the 10, it is stored at the after the 10, and the right child of the 10 is 5, and that is stored at the 2I plus 2, means 2 into 0 plus 2 means second index. And further 8, 4, and 2 and 3 that are also stored in a array. So deserialization means we have to store that information in some data structure that we can transfer from one computer to second computer, and second computer can extract that information and reconstruct the binary from that data. Okay, so I think array can be that data structure in which we can store the data values of the our binary tree, and from the another computer we can also reconstruct our binary tree. That is my assumption, but now see. The opposite operation, that is extracting data structure from stored information, is deserialization. Okay, now see example. If I have binary tree 1, 2, 1, 2 and 3, and the 2 null and null, 3, 4 and 5. Okay. Now see, after serialization 1, 2, 3, 1, 2, 3 and hash. Okay, they are considering null value as hash. Okay. After deserialization, original tree back. Okay, explanation. Okay, 1, 2, 3 has. Okay, they are also following the array technique. Means we will make the array of the array, and then what we will do, we will store the each information. Okay, now if I have 1, 2, 3, minus 1, 4, 5, minus 1, 1, 2, 3, minus 1, 4, 5, minus 1, out after serialization 1, 2, 3 has, okay, 1, 2, 3 has 4, 5 has, after deserialization original tree back. Okay, now explanation, any algorithm that compress that binary tree to string which can transmit it from which the binary tree can be reconstructed later can use here. We use the serialization algorithm based on the level order traversal where comma separates the nodes and hash denotes the null nodes. 1, 2 and 3, 4 and 5. If I have, okay, they are using the serialization. Now see what can be the approach. Okay, now for serialization. Now first see what I can think the what can be the approach for this. Now I have, where was it? Oh no, serialization and non-serialization. After serialization, after 1, 2, 3, 1, 2, 3, has 4, 5 has, after serialization, only tree will be back. That compares the binary tree to the string which can transmit it from. Okay. Now see the serialization, how the serialization takes place. Check if the tree is empty, if the root is null, return empty string. Okay. Oh, suppose if you have a tree, but if I say root is null, means there is no tree, and what we will do? We will return the null. And if the null is returning to, I send null to the second computer can easily construct the binary tree from that. Means null binary, nothing there. Okay. Now second step, initialize the empty string to store the serialized binary. Okay. I am considering here the array, but the here this website tab website is giving the string. Okay. So wait for a second. Now initialize the empty string to store the serialized binary. Okay. Now third step. Use the queue for the label order traversal. हम label order traversal initialize the queue in the queue and queue the root. ठीक है. Build the label order traversal loop. Decue the node from the queue. Okay. It means basically we have to do the BFS on that tree. Okay. Node is null. Append. Okay. Hash to the string. If node is not null, append data value along with comma as a delimiter. And enqueue the left and the right children. Okay. Return the final string containing the serialized. Okay, I understand it. Now solve this example. Serialize and deserialize the binary tree. I have one question. Serialization. One, two, and null, null, then three, one and three, null, four and five. I don't know why this is so hard. There can be some trick in this question. No, but why this is hard? It is so easy. Okay, now we have to just try the BFS on our tree, and if there is no node, means if there is a null node in the left or right subtree, then what we will do? We will append the hash in our the string with the comma. But here we okay, here we have to return the string. Okay, this is the string. Okay, along with the comma. What we will do first? We will okay. Now our the behavior will return everything. Okay. Now if you say or BFS, okay, call the BFS. Simple first, write the simple code for our algorithm, and we will attach the everything or every condition or bounding functions. Now I will pass the root, okay, root along with our string s. I am considering string s. Now define the string as equal to first I'm considering the input string. And I am passing that string to the function BFS. Okay, BFS will do that work, and after that, what we will do, we will return the s. Now be complete. Oh, what it and this is decode your encoded data to the tree. It means we have to we want two things. Classification: the input and output format is same as how LeetCode serialize binary. First, see how LeetCode support stem data structure. A data structure that holds statement sequence, binary tree. Now empty tree 1, 2, 3, 1, 2, bundle 2 to 3. Serialized format 1 null to 3 is not a array, but a way to represent the binary tree in the printable format using the level of diversity. The tree is traversed level by level from top to bottom, left to right. A null value is used to indicate where the value is missing in the binary tree, and it shows that there is no null represent in that position. Help you to understand the overall shape of tree, especially when some branches are incomplete. It is empty array but represent an empty binary tree where root is represent to null. ठीक. Now empty to null C++ null Java C Sharp Python or null for Python and Ruby. Now if you not always use the provided tree node and class type, not declarative serialized format. Now serialized format. But 1 to 3 is not an array but an equivalent linked list of later binary tree serialization. If I add the algorithm, okay. Decode your encoded data to the tree. String it will be given the data. We have to construct the binary. Here we have to what do you have to do? Okay. Here the you have to construct a BT from scratch. Okay. And here we have to construct. Here we have to print the values of binary. Okay. Now for first see the serialization. How can we serialize the binary tree if we have given the root? Okay. First we will take the empty string. We will call BFS and pass the password string. Okay. Semicolon. They not Python, but okay. Now write the BFS function. Okay. Now if you see BFS, I have three node. Okay. Three node and I have also a string. Okay. Passing my reference. Pass by value. Okay. Why I'm passing my reference or passing my value here, you have to write in a comment if you are seeing this video. Okay. Now come our solution. Okay. Now the see the template of BFS. First I will explain the template of BFS, then we will go to our solution of our question. Okay. Now in the template of BFS, what we will do, first we initialize the queue. Okay. So I have queue of integer, queue of okay, there's some mistake in my okay. I name here as a queue. Okay. Now I okay wait. Here we have three nodes. So we will queue of type node. Okay. Queue dot push, but I will push the root node in the okay queue. Okay. Now I have to now my queue contain the root node. Okay. Now I will pop the elements from the queue accordingly, and we will mm, visit the element one by one. Okay. Now for the condition, while queue dot em empty, जब तक queue empty नहीं हो जाती तब तक हम क्या करेंगे? Okay. First we will visit the root node. Means if I say okay, we have one. If there are two child, I'm here and okay, root. Now if I say tree node, now what will be the current? Means the current value, and that is on the current value of the queue. Okay, I write queue dot current. Okay, now I have now what current content? Current content the value that is root. Okay, now we will visit the left subtree and the right subtree from the root. Okay, if I say if I have current queue, okay, and what we will do, we will first should I push that in our string, that current value or not? Okay, let's think about that. Let's try run. So do we push the current value in the tree here, or after checking the condition right or left exist or not? Okay, if I have one queue, okay, and we have the current value as a 1, we remove 1, or if I push into the string contain 1, after that comma. Now I have, now if I try if left of 1 exists, if 1 of left exists, 1 of left yes exists, then what we will do, q dot push 1. Okay, if right exists, okay, then what we will do, q dot push 2. Okay, q dot push 3. Now the 2 and 3 is in a queue. Now if I remove the 2, then string will be the 1 and 2, 1 and 2. Now if I check if right exists of 2 or not, the right side exists of 2 or not, or left side exists of 2 or not, exist or not. No, there is no child node of a current node 2. What we will do, we will come in the else situation and we will push hash hash up. We will push, no, we will add the hash in our string, and we will not push anything in our queue. Okay, now for same for the right condition, we add hash in our string and we will continue. We do not go for the push the any element in our queue. Okay, but we have to take the extra burden. Now if you see tree node, okay, now s plus equals to of tree node current of value s plus equals to, first we will convert it into the string. Okay, to string current of value of the current. Okay, now we will check if current of left exists, it means there is some value or there is some left child of the current, and here current is 1, left child exists, yes exists. So what we will do, we will push the left child in the queue. Okay, so uh, q dot push current collect. Okay, and here now if I say the left side of current doesn't exist, then what we will do, we will we will not we will not push anything in our queue. But remember one thing, a question is given if there is no child of that current node, that what we are doing. If there is no left child, then we are pushing hash in our string. Okay, so what we will do, we will hash plus equals to hash. Okay, so what we have here, s plus equals to hash. Is it right? Okay, Now same thing for right subtree. Okay, here we can write right, here we can write right, and add plus equal to hash. Okay, we are not putting in the queue, we are adding in just in our string. Okay, now our string contain like our string can be 1 then 2 without comma, 1 2 3 hash hash 4 5. Okay, 1 2 3 hash hash 4 and 5. Okay, if you say the anything of 4 and 5, no, no, let's press equal to star. Can we no see, that is only DFS VFS question. Now you can the number of nodes in the tree range 1 to 10 to the power 4. That can make the after that. Now see. Overlap into the sequence of bits so that it can be serialized in general. Serialized and deserialized binary that there is no restriction on how your serialization and deserialization algorithm would work. You just need to ensure that binary tree can be serialized to a string and this string can be deserialized to the original tree structure. First, I'm just running it. Okay, there's so many incompleteness here. Here of R. Here 0 or R is not defined. Case 1 given and okay. Input is given. We have already input is given. One GPFS we add into the S in the string. Okay. Now what we have to do, then we first it will call for one. Okay. Now one will generate another string, then call for two will be another string, then for three will be added in our string. Now for the left child of 2, null means hash, right child of 2, null means hash. Now left child of 3, 4, right child of 3, 5. Now there is no child here. What we will do? Okay. The BFS is good. Okay. Now first mm, examine our BFS. Okay. Is it right or not? Okay. We will string as what we will do first we will go in a BFS. Okay. Here. First we check our BFS is it wrong or right. Okay. Here we can make one folder. Okay. Make one folder tree down history. Okay. Move the tree folder outside the graph. Okay, tree here, graph here, open tree and make one file and that is make a file name cdi dot cpp. Okay, now this is our BFS and first we have to try the our BFS is true the means our BFS is giving the right value or not. Okay, now first we have to have autocomplete for me. Please to complete this main function. I just want to check if our BFS is giving the right value or not. Okay. Complete, please complete it. Fast. Okay. Am I audible? Okay. Please, yes. Just complete my function. Okay. Please be completing my function. Okay. Strings here. We are calling BFS here. BFS the printing our value. Okay. We want to print the string as a undefined y. It should be defined has include a string. Okay. Okay, take बात I think that can that is for think that should work. Now for the tree answer can be one of left, two of right, left of left, four. Okay, left of left, four. रूट के लेफ्ट का राइट, लेफ्ट का राइट, लेफ्ट ऑफ okay. Now it can be 1, 2, 3, 4, 5, has. It should print like this. Okay. Now terminal, what you will do, right click and encode. It should print 1, 2, 3, 4, 5, has. Now what is the answer for this? I not type a BFS of root. BFS of root, and here we have T node of star root. BFS of root type conversion before. I just want to check if my BFS is good or not. I can easily check this. Why should I come here? Okay, let's close that window. Close that window, close anyway. Okay, now I can easily verify our BFS function. My BFS function. My BFS function. This is my BFS function. Okay. Now check. Now this will check the output of my BFS. Okay. Okay. Paper is correct. Serial entry, but the code has three important ones. Number one, current q.run or q.pop is a man here. I always forget about this. Okay. Now, S plus curve does not modify the S delay to string should be to string current value or S plus equals to where I'm writing wrong. I have written no, you need separate. Suppose value are 1 2 3 versus 1 2 3. Without separation, both could become 1 2 3. So use something like comma. Okay, and then root equivalent for otherwise. Current plus root plus null pointer, then current left crashes. Okay, we have some errors here. If I say if root equals to okay root is null, then what we will do? We will just return here. Okay. Now correct version of your approach. Now if the correct version of my approach is this. What is this? It given the array is not defined. Deserialization. Okay. Now for this, return a BFS serialization 1 to 3 has hash 4 5 hash. Okay, this is the serialization deserialization problem. I can show how could we see deserialization. Oh, I have just now I have to add the comma. Okay, so what I will do, I will correct top right commas comma and two string current value equal to comma area to comma area to comma. Okay, you have to just add one comma with it. Okay, comma with it, comma with it, and two string plus comma, and here two string plus comma. Okay, now this is the function for the serialization of our binary tree. Now for deserialization of our binary tree is, however, there is a deeper problem with the serialization approach. Implement deserialization afterward, you are adding a star immediately when child is missing. One queuing not null node. It can work with carefully designed decoding. But cleaner alternative approach is to put null node into the queue to and serialize the queue. Now we have done the serialization of our binary tree. Now, if I serialize the binary tree and we have the data like 1 to null and 4 5. Okay. Now, if I send the data to the another computer, then how it will know that this is the binary tree? We have to also design the deserialization algorithm to extracting the binary tree from this data. Okay. Now see the deserialization algorithm. Now for deserialization algorithm, we will think about the previous step that I already told you, like root will the position of the root we can consider at I, and left child is 12 plus 1, right child is 12 plus 2, and so on. Okay, now see, we are studying serialization and not the approach of serialization. Now deserialization. Check the serialized data is empty. If it is, then return null. Okay, now tokenize. Serialized data using the string stream with delimiter. Read the first token. Create the root node with this value. ठीक है? We are just okay. It is this is the first value that we have to create the node and add it to the root node. Okay, now use the queue for the lever traversal and initialize the root include the root. ठीक है? Within the lever traversal loop, dequeue the node from the queue. Okay, one. Read the value of the left child. Means what it means. We are deserializing the serialize string 1 2 3 4. Okay, so read the first value of string stream. Okay, and create the root node. Now we have to create the root node with this value. We create the root node 1 as with this value. Okay, now second step. Take the rest two values from the string and add them as a left child and right child of popped node. We pick the 2, and that is the second, and 3, that is the third value from the serialized string, and we add 2 at the left child of 1, 3 at the right child of 1. Okay, that is good. Now, sorry, for third step. Okay, we are picking two value every time. Okay, now we are picking hash and hash. Okay, so in 3 for 2, the left child will be the null, right child will be the null. Okay, for now for 4 and 5. 4 and 5. ठीक. Now for 3, 4 and 5 left is 4 and 3 5. Okay, push into the queue. Now for 4, hash and hash. And now for 5, hash and hash. Okay, now for 1 as a root node. ठीक है. Queue 3 node data. ठीक है. Complexity analysis. Time complexity order of n, serialized debugging order of n, deserialization order of n, number of node entry, it can be the order of space we serialize. Node. Okay, now see the how can we deserialize. Okay. We create the string, okay, and we return that string as. Now we have to deserialize the data from this string as. Okay, if I say if s dot empty string data. If I say data is empty, मतलब there is no serialization string. Okay, so what we will do? We will just return null. Okay, now for the first value. Okay, if the data is not null, means there is at least one value in the data. Okay, so what we will do? We will create the first node. Okay, so we can say t node star root. To new node, and we will data of 0. Okay, pass the data of 0. Okay, now we create a one queue of 3. A queue. We will push the root node in the queue. Okay. Okay. Now we put the queue in the root node. Now apply the template file queue.py. जब तक क्यू एम्प्टी नहीं हो जाता तब तक हम क्या करेंगे? ओके, जब तक क्यू एम्प्टी नहीं हो जाता उसमें से पहली वैल्यू निकालेंगे. ठीक, तो जो पहली वैल्यू आ जाएगी उसको हम बोलेंगे रूट नोड. तो आ गया. ठीक, उनमें टी नोड स्टार current equal to q.front. Okay, now we also have to pause the queue. Now we remove the front value from the queue. Now check if I have the string 1 2 3 null null 4 5. Now 1 become the root. Now take the two elements from the string. Okay, how can we take the two elements from the string every time? I and I plus 1. Second time I plus means we have to put that string as a stack, or can we element as a stack? So we can easily pick two up two elements from the stack. Okay, what can we ever instead of a stack? What we can do? First element 1, the second element is comma in our string. Okay, so what we will do? Now see, decrease node from the queue is the value from the okay. Read the first token and create the root node with this value. Read the first token, create a node with this value. Okay. Use the queue for the level or traverser, initialize the queue and enqueue the root. Within the level or traverser loop, decrease the root node from the queue, read the value for the left child. Star read the next value for the left child. Star set the right child to the null. Otherwise, create a new node and set it to the right child. Okay. If it is star, then set a left child to null. Okay. Otherwise, create a new node and set the left set as a left child. Read the next value for the right child. If it is star, no, it's not star, it is hash, then set right child to null. Otherwise, we create a new node and set the value that is given in the string. Okay. Now include the left and the right children into the queue for the further traversal. Return the and reconstruct the tree of return the reconstructed root of the tree. Okay. We are going everywhere, so how can we traverse? We have to just traverse for string now. Okay. Deserialization, data into eternal. I can remove this, I think. Okay. I equal 0. No, I can start I from if there is only one child. Two. How can we know that there is no start size? Okay. I and I plus 1. We have to jump every time 2 steps. What we can do after 2 step jumping? Here we have the code for the serialization, the returnal in order. We are in order. Okay, now serialization. We are doing the VFS. Now deserialization. How deserialization is working? Now data is coming as a string, data empty is return null. We have done this so far. String stream as data, string str, string stream to pass to the input data. String stream to as data. Now we have created the object of string stream. String stream and as of data. Now t node new node story. Okay, create a new node. Initialize the queue to hold the string. What it is if string node equal to hash, then create a new node. T node left node equals to new tree node to your str. Root का left equals to left node और queue में push कर देंगे. Okay. Now what is this? Remove this and now deserialization in and deserialization how the string traverser. String traversal. How can we traverse the string? Okay. Now see, if I have 1, 3 and has 4, 5 SSS, we have constructed the string. Now it travels it token automatically means 1, then 2, then 3, then has and 4 and 5. Not character by character. This matter because note can contain 1, 200 or -5. Simple way string. Simple data 1 to we have the simple data string. We created the string message from that data. Okay. Now string string of token. We create one string token while get line as token comma cout output will be 1 2 3 s 1 2 3 s. Okay. Means get line as token. It means each character until comma is found and store them in token. Okay, while get line as token. Now look at this thing. Get line as a token. That is very important for today. Okay. It means read the string. Okay. Where what is SS is string. Read the string. Okay. And if you find from if you find comma, then store it in a token. Okay. So we see out the token every time. Okay. Now instead of doing the cout, we can store it in another string token. We can token plus. Okay, 15 token 150 now. Then you can convert the real node value using int value story of token. For VFS serialization, we just follow deserialization. Create a root equal to 1 ठीक है now q1 q में 1 को डाल दिया now next token is what 2 ओके तो ट्री का लेफ्ट आ जाएगा 2 नेक्स्ट टोकन आ जाएगा 3 तो ट्री का राइट आ जाएगा 3 ठीक राइट चाइल्ड ऑफ 3 ऑफ 1 3 राइट चाइल्ड ऑफ 1 नाउ क्यू में आ जाएगा 2 and 3 नाउ नेक्स्ट टोकन है हैश लेफ्ट एरो टू रन नेक्स्ट चाइल्ड ऑफ हैश नन राइट एरो टू नन ठीक नाउ क्यू में 3 नेक्स्ट एरो 4 to 4 नेक्स्ट एरो 5 so are to queue the traverse the tree parent while the cat traverse the select data string token. Okay, so main thing is the Catalan serialized stream means string stream. Okay, now we understand string stream. We are doing the string stream and we are generating the token every time. So instead of generating the token, what we can do? We get the token. Okay. What we will create the root node and initialize at the token. Okay. Now initialize a token and we add it into the queue. Okay. Now while queue is not equal to empty, what we will do? We will remove that token. Okay. Remove that token. What we are doing? Now create new node created one. Now after that, what we are doing? Next token is 2. Okay. Next token can be customization. we have to deserialize this that string if data dot empty. If it is empty, okay, then what we will do, we will deserialization of string. Okay, now deserialization, how deserialization work? It work like data empty return null. Okay, now we create the string stream as from that data, and string str means that token. Okay, read the root value from the string. Okay, string str, read the string value. Okay, create a new node and str, create a new node and str. Okay, now queue, we create the value, create the queue, or push that root node in the queue. Okay, now while queue is not equal to empty, we create a new node, or we pop that node. Again we get line as, again we read the left child value. Okay, the left child value, if it is hash, then we create a null node. If it's not equal to it, then we create a null a node and attach to the left and add it to the push. Okay, for the right, same thing will be here. Okay, now see, if the data is empty, okay, now string s, string ss equals to, we create string ss from that data. Is it right way to write this? Okay, now see, string stream stream as, then data value, then we get that token. Okay, stream ss, then data value, then we get the string. Okay, string token. Now if we get a node and we add as a root node. Okay, now tree node star root. Okay, new new tree node, and we can pass the token inside here. Okay, can we do that? Okay, read the root value from the, but we have to read the, here is the string, but for reading purpose you have to write get line as str then comma. Okay, for reading purpose you have to write get line as ss string comma token comma that string token and that comma. Is it right? Okay, string now s, then token, then comma. Okay, now s, then token, then comma. You get line this. Now we can create a new node and attend that token. It is string, so we have to convert it into the integer. What we will do, we will create a story function. Okay, okay, now tree root contain the one. Okay, we create the queue of tree node. Okay, now we create the queue node and queue dot we push the push root value. Okay, now check for the if q dot empty. Okay, while q we are just trying the bfs every here we are also trying the bfs. Okay, now if I say first the find the left value from that string left value. Okay, but we will get find string comma the token comma. Okay, we find the left value. Now see in the if we token is not equals to what token is not equal to like this, then what we will do, we will create a new node and assign the new node as a left child of that tree. Okay, what we will do, we will create a new node tree of t node star equals to new left. Let me be creating just l. Okay, l equals to new tree node and assign the value of that token. Okay, we assign that string is to value. Okay, token creating the new node, assigning it to the queue, and also we are pushing it into the queue. Q dot push equals to L. Okay, Q dot push equals to L. Now see the for right child. Okay, same function for the right child. Okay, token not equal to not t node. Here we can write R, creating a new node and adding into queue. We are not adding into. We can add. Okay, current top. Okay, tree node star current equal to q dot front q dot pop. Okay, what we will do, current of left equals to L. Okay, now get line here of to right to token. Here I can write current of right equals to R. Okay, now we can push it into R into the queue, and here we can return the our root node. I think there can be some mistakes, then I will solve that mistake and again. Okay, now the test is I'm coming. Okay, wait just a second. Hello, hello. हाँ, लैपटॉप की कैमरा से करता, फोन कैसे तो अच्छी आती ना। मैं तो ऐसे ही करता था, हमको मजा नहीं आ रहा था तो मैंने कर लिया यार, क्या करें। सो जा बेटा, साली तुम ही, मैंने देखा नहीं यार। ये कौन था? एक दीपक। debugging. I don't know. Hmm. चलो मैं भी अब सोऊंगा थोड़ी टाइम से। वही यार यार। Okay, here I am back. Now see the okay. Observe that invalid test case. Why? Imagine OR is not defined means what it means. OR is not defined. Decode your encoded data to tree. We have activity from the data we have updated. Data is coming, we are converting that data into the string stream, and after that okay. Now see if BFS is good. Okay. Serialization is good, but on deserialization is not good. Okay. Where we are doing tree data, string stream SS, string token, get line SS token, create new node, okay, and assigning it the token. We are creating that another tree node, pushing into the queue, and every time we are popping from the queue and visiting that vertex means that node. If it is not equal to that means there is some value. We are assigning that value. Okay. What I can do that in this. Okay. Is there any mistake? Okay. With this function and here and this while loop and here and this function and here everything is good, then why it is showing me the name dir is not defined. Let's search about it. Name OI not defined is standard programming error only if the word or variable function keyword word computer does not define it. Case sensitive. Logical or Encoding the value, deserialization, then mistake, string token, guideline access, token D, Q, okay, was root, date, okay, second mistake, let's find that mistake. Can we show many mistakes? Let's check on no. Last coding, decoding. String as root not equal to null return. Okay, root null and return. Queue of tree node. Okay, we find this mistake. Star. Okay, now queue empty. Tree node current q dot pop string s equals to string plus this q dot post s plus equal to s s plus equal to s q dot post s star s plus equal to star. Okay, s plus equal to current of value. Okay, our tree node return variables data string tree node. Okay, here O is capital. Tree node here nothing is capital. It should work now, I think. Why this is getting tree node of tree node R. Node is 2. Getline is token, comma, tree node star R. There's a mistake. Again, there's another mistake. Let's find. Okay, now code as a public void behavior tree node root. It is good, but I can also your root equal to null then return q of tree node star q dot push root. Okay, while q not equal to empty tree node of current equal to q dot front. Current आएगा q dot front q dot pop s plus equal to 2 string current of value comma if current okay if current of left like this then q dot push current of left. Okay, now I can okay, okay. current of right. Then if current of less than current was current of right, current was current of right. Else s plus equal to hash. Okay, string as web has root string as. If data is empty, return string as data. Edit string. Now string token and get line as a token comma. Tree node root equal to new tree node and to your token new of invalid text case. Keyword for get line as token node equal to here, string node equal to new tree node is to of token. We are converting the value story of current to left equals to L. Current left equals to L. Keyword was equals to keyword was equals to L. Okay. Get line equals to SS token. Trigger token not equal to has current राइट के लिए स्ट्रिंग ऑफ टोकन करंट का राइट आर क्यों हम पुश कर देंगे कि आर को रिटर्न कर देंगे रूट को दैट्स रियली करेक्ट ओके where I can change my code okay note current left token it will give the first value we can check content like we have to check it in string let's try it once okay plus equal to what okay left node cause was now the LH string current of left current of right ls plus equal to okay but what is wrong comma t node equal to q comma token not equal to this token not equal to this current new node is to of that token string 20 here current left no get line take not token not equal to hash take this should be correct but why this is giving wrong answer means invalid input by let's check it first why they give me invalid input there's one mistake here. Why? I'm not understanding. Why are they giving wrong answer? QT node QUE Q node of T node equals to Q dot power base plus 2 string current of else else. Take a kind of brand. current pop to string current left exist in current left. Trying with this. Now we can try with like this. Okay. First, what we will do, we just have to first add the hash before adding to the. Okay. Okay, now I understand. What we have to, we have to just add the hash value before that the node value. Okay. In a serialization function, that is the BFS function, what I can do, and before pushing the current value, what I will do, I will check for the current node, and that is the q.push if current equals to null. if करंट ही नल हो तो हम क्या करेंगे, स्ट्रिंग में ऐड कर देंगे क्या, हैश को. ठीक, स्ट्रिंग में ऐड कर दिया हैश को, कॉमा को, और हम क्यू में भी पुश कर देंगे. यहाँ करंट नल हो गया तो नाउ चिकन कनेक्शन में आते हैं कि करंट नल हुआ तो ये कर देंगे, करने के बाद हम क्या कंटिन्यू कर जाएंगे. ओके, नाउ अगर करंट नल नहीं हुआ हम क्या करेंगे, उसको कन्वर्ट करेंगे इंटीजर में, स्ट्रिंग में, और स्ट्रिंग में ऐड कर देंगे. ओके, और लेफ्ट के लिए पुश कर देंगे. यहाँ पे कंडीशन की जरूरत नहीं है, ऊपर कंडीशन लगा ली अपन ने. नाउ deserialization and deserialization function reduced like this. Current of left, we can use that condition. This condition can also be used. Now we have just call for the q.push left and q.push. This can be one left and q.push left, at just left and at right. Current of left. Okay. Current of left, current of right. Current equals to null. Organization system as considered. Current equals to q.current, q.pop. ओके, नाउ करंट ही नल हो गया तो हम क्या करेंगे, स्ट्रिंग में ऐड कर देंगे हैश और कॉमा को, उधर से कंटिन्यू कर जाएंगे नेक्स्ट वाले वैल्यू के लिए, मतलब नेक्स्ट वाले चिल्ड्रन के लिए. अगर करंट नल नहीं हुआ तो हम क्या करेंगे, स्ट्रिंग में ऐड कर देंगे करंट की वैल्यू है उसको स्ट्रिंग में कन्वर्ट करके और कॉमा लगा के. बट स्ट्रिंग में हम ऐड करेंगे तो कॉमा को ऐड करेंगे या फिर हम करेंगे स्ट्रिंग ऑफ कॉमा को ऐड करेंगे. ये एक हो सकता है अच्छा so many time taking that क्यों रिपोर्ट करने आई ओके let it come let it okay invalid test case majority error this is failing test input output format is same as how LeetCode serialized binary. You do not necessarily need to follow this format, so please be creative and come up with a different approach yourself. Okay, none or is not defined. Okay. invalid test case. This is how a code subject will be instantiated and called as such. Code set the codec object will be initiated and called as codec ser and er. T-node answer equal to T-node answer equals to deserialize. Deserialize. Okay. What I can do here. Okay. Now I'm gonna select the Java. Okay. I'm gonna select C++. Then I'm gonna run it. Let's think about the question. Okay. Now I just saw, saw the solution, and one of the guy write like if root equals to null, then return root equals to null, then return. Okay. So if what I will do, if root equals to null, then I will s equals to okay, as a questionnaire, and then return. Okay, where the I at the has I can write null. Okay, I can write null where I can write. Okay, something is missing here. But the command did not give pause can the questionnaire express questionnaire or express questionnaire now. Null continue to string and value content. C line string as VFS return as data equal to any variable. Data dot empty null modified equals to data color return null string as token as token. टोकन null है ठीक टोकन null नहीं है तो क्या करेंगे again mistake what should I do now right data stream data get stick now do not go to there okay now for the right child get customer without checking whether the candidate actually found another token accept solution check this okay there is some mistake in our code and that is what if the next character is not present but this function is trying to fetch that value that comes before the comma so what we will do we will add one condition before it and that is this अगर वो वैल्यू नहीं है तो हम क्या कर देंगे ब्रेक कर देंगे इधर से ही वो वैल्यू है 5 This should be correct now. Okay. And for the left child we have to do. And for the left child. Okay. Now what you to do it. Okay, there's some error in LeetCode test case session. I plus code and that are same in my code, but they also they are also doing the same error. I think there's some mistake, or I can say editor error. Okay, सेशन हो सकता है या फिर okay. Can I write this another test case? Delete that test case. Instead of this, can again write this. Okay. Can it will okay. It is editor or UI issue. That's an issue. Okay. Now the approach will be same that I saw. Okay. That's all for today's live, and we will be back. Okay. After I don't know how after how many days, but yeah, that's all for today. Thank you who will watch my stream in future. Thank you everyone.